If you want to find the domain of a function analytically, essentially what you're going to look for are the things that cannot be included in the domain. These values are found by things that would cause division by 0 or cause a negative square root. I've included in here other wonky stuff because maybe you have a weird piecewise function or something, but for the most part, these are the two things that you're going to look for: division by 0, negative square roots. So, what I mean by division by 0 is I mean that you have to have some x in a denominator. So in number 1, I don't have any x's in a denominator. I don't have any square roots, so I can't have either one of these things. So that means the domain is just going to be negative infinity to positive infinity. With number 2, I do have square roots, so I need to figure out what would cause this to give me negative square roots, and that's going to be excluded from my domain. Or another way to think of it is to think of what things can be included. So I can say x minus 3 has to be greater than or equal to 0. It can equal 0, that's fine, the square root of 0 is just 0. But the square root of any negative number, like the square root of negative 1, would be a non-real result, so we cannot use that. So x has to be greater than or equal to positive 3. So my domain will include 3 and everything above it. Now with number 3, I want to look for all of the values that will cause division by 0. So I'm just going to say x squared minus 1 cannot equal 0. And I just need to solve this. So I'm going to factor it as a difference of two squares. So x cannot equal 1, and x cannot equal negative 1. So the way I represent this in interval notation is I essentially want to do, let's start with the negative 1. I want to do everything less than negative 1. Okay, so from negative infinity up to negative 1, but not including negative 1 because we can't include it. That's a not equal to. And then everything between negative 1 and 1, so that's represented by negative 1 to 1, and everything greater than 1, so 1 to infinity. Whenever you have things like this is essentially a whole. The way you represent a whole is you just put the value that you're excluding in with parentheses around it with a union, between the two intervals. So if you have multiple ones like this, you just kind of use the union to include all of the intervals, excluding those wholes that you're pulling out here. Okay, let's try this one. I don't really care what's going on with the numerator. All I care about is the denominator, because that's going to tell me what will cause division by 0. It cannot equal 0. So this factors to x minus 5 and x plus 1. So x cannot equal 5 and x cannot equal negative 1. So we're going to do the same thing with this that we did up here, where we have these two wholes that we need to break up. So we're going to go from negative infinity up to the smaller one, then from the smaller one to the bigger one, then from the bigger one up to positive infinity. Oops.